So children, to begin with, Standard 10th Mathematics Part 2 Coordinate Geometry, that is lesson number 5, video number 13, dealing with practice set problems. Let's move on with the second problem. Let's see what the problem says. Verify that the points P, Q and R are the vertices of a right angle triangle. Now how do we determine if the three vertices form a right angle triangle? For this, we should know the converse of right angle triangle theorem. What does it say? It says that when you have three measurements of sides given, three lengths given, the square of the highest number should be equal to the sum of the squares of the other two sides. That means we are supposed to calculate over here the distance PQ, distance QR, distance PR. That means length PQ, length QR and length PR. And then by applying converse of right angle triangle theorem, we will decide if these 3 points are forming the vertices of a right angle triangle. So here, how do we calculate the distance between PQ or QR or PR? Again, we have to use the distance formula. So first, distance PQ. Let's first jot down the distance formula. What does it say? It is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's assign the values of x1, y1 and x2, y2. As we are considering points P and Q, definitely the coordinates of P will be assigned as x1, y1 and the coordinates of Q as x2, y2. Let's move on. So here distance PQ will be equal to x2. What is x2 over here? 2 minus x1 is minus 2. So let's insert a bracket because both have got a negative value. The whole square, let's not forget the square, plus y2 that is 2 minus y1 that is again 2 the whole square. Thus distance PQ is equal to, now here let's solve the terms inside the bracket. 2 minus into minus gives us plus 2 the whole square plus over here plus 2 minus 2, definitely you can cancel, it is 0. So we get over here only 0 square. Thus distance PQ will be equal to square root of 2 plus 2, the first term we are finding out, is equal to 4 the whole square plus 0 square is 0. So distance PQ is equal to just 4 square, that is 16. So here again we take only the positive value of root 16, that is plus 4. Discard the negative value, that is minus 4, as we are calculating distance. So we'll have to choose only the positive value. So distance PQ is equal to 4 units, or you can say therefore length PQ is equal to 4 units. So we have done with finding the distance between PQ, that is length PQ is equal to 4 units. Let's now calculate distance QR. What do we use again? We'll again have to use the same distance formula by assigning the values of x1, y1 and x2, y2 depending upon the points that we take. The points that we take over here is Q, R. So over here, let's shift the values of x1, y1 and x2, y2. So x1, y1 will be the coordinates of Q, and the coordinates of R will be x2, y2. So over here we are finding our distance QR. So over here the coordinates of Q are x1, y1 and coordinates of R are x2, y2. So we are calculating distance QR. So again with the same formula, to calculate distance QR. x2 is 2 minus x1 is again 2 the whole square plus y2 is 7 minus y1 is 2 the whole square. Thus distance QR is equal to the first term. Let's solve it. 2 minus 2 gives us 0 the whole square plus 7 minus 2 that is 5 the whole square. So distance QR is equal to 0 square is 0 plus 5 square that is 25. So distance QR is equal to 0 plus 25 is square root of 25, and we know, children, that square root of 25 is again plus 5 or minus 5. We will discard the negative value as we are calculating distance. We just take the positive value, that is 5 units. Thus we can say length QR is equal to 5 units. So what did we get over here, children? Till now we got length PQ. I'll jot it down over here. Length PQ was 4 units. Length QR is equal to 5 units. What are we left with now? We are left with to calculate distance PR. So again with the same formula, which gives us as square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's not forget to assign the values of x1, y1 and x2, y2. What is x1, y1 now? As we are taking point P, the coordinates of P will be x1, y1 and the coordinates of R will be x2, y2. So distance PR will be given by x2. x2 is 2 minus x1 is minus 2. So let's insert a bracket, a double bracket with the square which not has to be forgotten, plus y2. What is y2? Over here it is 7 minus y1 is 2 the whole square. So therefore distance PR will be equal to, let's see what is there in the first bracket. 2 minus into minus gives us plus, again with the 2 the whole square plus 7 minus 2 that is 5 the whole square. Therefore distance PR is equal to 2 plus 2 gives us 4 the whole square plus 5 square that is 25. So distance PR will be equal to 4 square is 16 plus 25. So over here we get distance PR is equal to 41. So over here length PR we can say is equal to 41 units. So what did we do in the last case? We found out distance PR by assigning x1, y1 to the coordinates of P and x2, y2 with the coordinates of R to the coordinates of R. So x2 minus x1 plus y2 that is 7 minus y1 that is 2. We moved on with the calculations and ultimately we reached with the value of length PR as 41 units. So let's write it down. Length PR is equal to 41 units. Now the last segment to be solved and check if they are the vertices of a right angled triangle. As I told you earlier, children, we'll have to use Converse of Pythagoras theorem. How do we apply converse of Pythagoras theorem to decide if they form the vertices of a right angle triangle? Definitely we'll have to consider all the three answers. So let's jot it down. We got length PQ as 4 units, length QR as 5 units, and length PR is equal to root of 41 units. Length PR was equal to root of 41 units. Now, which answer or which number 4, 5 or root 41 is the greatest? Why? Because we'll have to square that number, and on the other hand we'll have to take the sum of the squares of the smaller two numbers, and if both the answers tally, if both the answers are equal, then we can say that by using converse of Pythagoras theorem, PQR are the vertices of a right angle triangle. But over here children, one number is 4, one number is 5, the other third answer that we got over here is an irrational number. How do we compare then? Which number is the greatest? So let's see children over here. What is the easiest way? Let's square and get the answers and then find out which number is the greatest. 4 square children over here will give us 16. 5 square is 25, and root 41, the whole square is root 41 into root 41, that is 41. Now it becomes easier for us to compare these three numbers, that is 16, 25 and 41. Now which is greatest? Definitely root 41 is the greatest number. 25 and 16 are the smaller numbers. So how do we apply converse of Pythagoras theorem over here? Definitely the greater number. Now it is easy for comparison. The greatest number or answer square, that answer should be equal to the sum of the squares of the remaining two. So let's begin. Over here we will have length PR, the whole square. What is length PR? Let's substitute root 41. The whole square is root 41 into root 41, that is 41 units. That means the square of the largest number, the largest answer we got as 41 units. Let's take the smaller two numbers now, that is 4 and 5. Let's sum them up by taking their squares. So here length PQ square plus length QR square. What do we get? We get length PQ is 4, so 4 square plus length QR, that is 5 square. What do you get? 4 square is 16 plus 5 square is 25. 16 plus 25 gives us 41 units. So what did we see in this case children? That when you take the square of the largest number, we get the answer 41 units. When we take the sum of the squares of the smaller two answers, we are again getting the same answer, that is 41 units. So we can therefore conclude that as length PR square that answer is equal to length PQ square plus length QR square. Once again I repeat, what are we concluding? As length PR square is equal to length PQ square plus length QR square. Why are they equal? Because the answers are equal. Therefore, PQR, therefore points PQR are the vertices of a right angled triangle. And how did we conclude this answer? By using converse of Pythagoras theorem. So children, as both the answers were right, which answers? The square of the largest number was equal to the sum of the squares of the smaller two numbers. As both the answers were equal, we could say that these points P, Q and R are the vertices of a right angle triangle. And what support did we take off? We used the converse of Pythagoras theorem. So what did we do, children? In all problems, if we see, we are just using the distance formula, and depending upon the conditions given in the problem, we are using, applying, and then if they are satisfying the conditions of that given requirement, then we conclude that if it's yes or no.